Hey everyone, and welcome to this explainer. Okay, so when you picture an island nation sitting right smack near the equator, your mind probably jumps straight to one thing, right? Relentless heat and constant sunshine. But actually, the truth about Sri Lanka's environment is way more complex and, honestly, super dynamic. Today, we're unpacking the atmospheric rhythms of Sri Lanka. We're going to uncover the completely unique engines that drive this island's highly varied temperatures and its intricate cycles of rainfall. Let's get into it.
Okay, let's dive into this. Is Sri Lanka always hot? It's a completely normal assumption to make. You see this gorgeous tropical island tucked just south of India, and you imagine a uniform, sweltering blanket of heat literally 365 days a year. But the reality? Sri Lanka is actually a land of massive atmospheric contrasts. There is no single temperature here.
Now, to really make sense of these contrasts, we have to look past the daily weather. Weather is just the island's short-term mood. Instead, we need to focus on the underlying climate. It's this long-term, overarching personality that truly dictates Sri Lanka's unique environment, rather than just, say, whether it happens to be raining this afternoon.
Section 1. Mapping the heat. So, let's look at the very first major engine shaping the island.
27 degrees Celsius, that's the overall average temperature across Sri Lanka. And hey, at first glance, that number seems to totally validate that initial assumption of constant heat, right? But averages, well, they can be incredibly deceiving. In this case, that 27 degrees masks some absolutely wild regional extremes that exist right within the country's borders.
We can essentially divide the island's temperature profile into two very distinct extremes. On one hand, the northern and lowland regions pull that average way up with really high, sweltering temperatures. But travel to the central highlands, to places like Nuara Eliya, the temperatures literally plummet. Just imagine standing in a tropical country, right near the equator, and actually needing to throw on a thick sweater. That extreme juxtaposition is exactly what makes this climate so uniquely fascinating. And this brilliantly illustrates the forces at play here. There are four distinct factors driving these temperature extremes. First up, distance from the equator. That sets your baseline tropical heat. Second, altitude. This drastically alters the air temperature as the land rises. Third is proximity to the sea, which moderates the coastal areas. And finally, seasonal wind patterns that carry completely different air masses across the terrain. Put them all together, and they form this invisible dance that creates that massive lowland to highland contrast. Now, out of those four factors, the ultimate defining rule is actually super simple. The higher you go, the cooler it becomes. The central part of Sri Lanka pushes sharply up into the atmosphere. As that altitude increases, the air thins out and the temperature drops rapidly. This elevation effect is the absolute main driver breaking up all that tropical heat. And, as we're about to see, it profoundly manipulates our next major topic.
Section 2. The Rhythms of Rain. Let's shift gears to the second critical engine, rainfall.
Rainfall is simply the amount of rain received in a specific period. But when it comes to capturing that rain, Sri Lanka basically acts like a giant catcher's mitt for a whole bunch of different atmospheric phenomena. The island doesn't just get one generic type of precipitation. It catches water from entirely different, highly complex systems. Specifically, there are three distinct rhythms of rainfall that drench the island: convectional rain, monsoon rain, and cyclonic rain. Each one of these operates on its very own schedule. They're driven by totally different forces, and they impact the island in very, very different ways. First up is convectional rain, which is 100% driven by heat. So picture this: the intense tropical sun rapidly heats the land and the moisture during the day. That hot, wet air rises, it cools, and forms these massive clouds, which eventually results in sudden, bursting afternoon and evening showers. It's basically a rapid, heat-driven cooldown, and it can happen anywhere across the entire country. Next, we have the absolute most famous of Sri Lanka's weather patterns, the monsoons. These sweeping seasonal winds literally divide the island geographically. From May to September, the southwest monsoon dumps heavy rains on the southwestern, wet zone. But then, the winds completely shift. From December to February, the northeast monsoon brings rain to the dry zone in the north and east. It's a massive pendulum swing of moisture across the island.
The final rhythm? That would be cyclonic rain. This is the wild card. These aren't your predictable afternoon showers or your reliable seasonal winds. No, these are violent, intense storms that mostly brew out in the Bay of Bengal before sweeping violently across the island. This represents the truly unpredictable side of Sri Lanka's atmosphere.
Section 3. Putting it all together.
Let's move to and see how this builds a complete climate summary. When we synthesize all this data, a really clear master schedule emerges. We've got those short bursts of convectional rain hitting the whole country, and that's layered right over the strict seasonal timings of the southwest and northeast monsoons. What does this tell us? It proves that the rainfall isn't random at all. It's actually a highly structured, geographically specific system.
So with all these converging systems, who actually gets the most rain? Well, the high rainfall is heavily concentrated right in the central mountains. That towering altitude basically catches those monsoon winds and squeezes the moisture right out of them like a giant sponge. Conversely, the northern, eastern, and southeastern parts remain much, much drier. The physical shape of the island literally dictates exactly where the water falls.
So, the crucial point is that Sri Lanka's climate depends entirely on location, height, and winds. It's not just about equatorial heat, not by a long shot. It's the location in the Indian Ocean, the towering central highlands, and the sweeping monsoons, all working together in this incredibly delicate harmony.
Which leaves us with one final vital question to think about. As global temperatures shift, will these delicate atmospheric rhythms remain the same? A change in the global baseline heat could alter those monsoons, shift convectional patterns, or completely change the highland profile. Understanding these microclimates isn't just about memorizing geography. It's absolutely essential for looking toward our future. Thank you so much for joining me in this explainer. Keep exploring, keep learning, and I'll catch you next time.